Hi, so today I'm gonna just show how to make this crystal shader right here. I made this a while ago when I was practicing some vector displacement, and I figured that it would be a good introduction to procedural vector displacement. So to start out, I'm just gonna use a plane right here, and it needs vertices to actually displace, so I'm gonna use a subdivision surface modifier. I'm going to set it to simple so it doesn't actually change the shape of our plane. And I'm going to enable adaptive subdivision. If you don't see adaptive subdivision, you have to go into your render properties and enable experimental feature sets. One other thing I do is I went down into this subdivision option here and I changed both of these to 1. That's just going to make it so in our viewport our subdivision will look the same as it would in our render. If you have a really slow viewport, you might want to increase this viewport resolution. By default, I think it's 8. But I'm just going to leave those on 1 just so I get higher accuracy. And we can start making the material. So the first thing we'll have to do with the material is go down into settings and enable displacement and bump. This is important because that's what's going to allow our material to move the vertices of our mesh. Now, we can go into shading view now, and my setup looks a bit different, but everything will still be the same in terms of how I make the shader. The first thing that we probably want to do is create a sort of hexagonal shape. We can think of it as like a cylinder being extruded up, but instead of the circle, we're going to make a hexagon so we get the nice crystal shape that we want. We can think about a hexagon in its 4 separate quadrants because we can just make a single quarter of it and then mirror it onto the rest. And we get this area right here that we want to create. We can see that this area is created from these 2 lines, so you really just have to create these 2 lines. This vertical line here is straight, so that's easy, but we have to figure out what angle we want this second line right here to be. And for this, I'm kind of briefly going over how we're making the hexagon, but if you want a more in-depth overview of the math, you can check out this really cool video by Art of Code on hexagonal tiling. It's in GeoSL, but he explains the math on how he makes the hexagon, and it's the same math we're going to use here. So to start, I'm going to use object coordinates. The reason I'm using object coordinates rather than UV is because with UVs, we go from 0 to 1 on the x and 0 to 1 on the y. But with object coordinates, we go from -1 to 1 on the x and -1 to 1 on the y. This is usually better than UVs when working with procedural textures because a lot of mathematical equations kind of they use negative values too, whereas image textures are only mapped from 0 to 1. For example, if we wanted to make a circle, we could use vector math and set it to length, which will get the distance to our origin. And if we go ahead and use less than, we've created a circle that revolves around 0, 0. Whereas if we use UVs, this would get cut off. So now we're going to make the hexagon. If we were to separate the x, y, and z values of our coordinates here, you can see we have these vertical gradients. And this black area actually goes into the negatives, so -1 to 0 to 1. This x value is going to be our straight line, and in order to make everything mirror, we're going to use vector math absolute. And the reason this mirrors everything is because now instead of going from -1 to 0 to 1, we're going from 1 to 0 to 1. So anything that happens in, say, this area over here is also going to happen in this area. And this will mirror our x and y quadrants, which is exactly what we want here. Now to create our second line, we're going to use a specific ratio that was stated in the Art of Code video. And we need to use a dot product. Dot product is really cool because it allows us to make a sort of gradient pointing in a direction based on a sort of ratio. So here if our ratio is 1 and 0, we get this horizontal gradient, but if it was 1 and 1, we'd get a diagonal gradient. And so the ratio that we want to use is 1 and the square root of 3, which you can enter by typing this in. This is the ratio that our hexagon is going to use, and we need to make sure that this has a length of 1. So what we can do is just normalize this vector here, 1 square root of 3, just to make sure it's normalized. And we've just made our two lines. If we were to connect the x and this new line together without mirroring anything, using math maximum, you'll see that we kind of get this shape here. And if we mirror everything, you can see that we get these 6 distinct areas here. This kind of looks like when we used vector math length to generate that circle. So now if we were to use math less than, we should see that we have a hexagon shape. Okay, so now that we have our hexagon shape, we have to extrude this upwards. Now the way height maps work is dark values are lower down and brighter values are higher up. The value directly correlates to how high a vertex is displaced up or down. So if we were to go ahead and add a displacement node and plug this into our height, plug displacement down here, you would see that it kind of extrudes up. And we want the plane to actually stay at 0, so we're going to set the mid-level to 0. That way it only extrudes everything upwards out of that 0 coordinate right there. And if we put on our principled shader, it looks okay, but you might notice that we get some really weird zigzagging issues here. The reason for that is because with displacement, you really never want to use a constant change in a value. You don't want to go from black to white instantly, or else you're going to get some weird issues there. So what we can do is use something like a color ramp instead. So if we went and plugged a color ramp into here, I'll disable the displacement so you can see what we're doing a bit better. Now we can move our sliders around to get that same hexagon shape as before, but we can give it this more gradual fall off here. And if we go ahead and plug that into our displacement now, you will see that we have no more of that zigzagging issues. We have very clean surfaces now. This is a pretty simple use for a color ramp, and color ramps can be kind of heavy, and so you can actually optimize this. If we use a map range node, you can imagine this as our color ramp, where this first slider is the position of our black knob here. The second slider is the position of our white knob, and these two change the brightness. So you can see we've got our black knob, which is set to 0, and our white knob, which is set to 1. So if we went ahead and copied this position here, and put it into our white knob, copied this position, put it into our black knob, and we plug this into height, nothing's going to change because everything is exactly the same. And that's what we want. So I'm going to just set this to, say, 0.4 and 0.3. So you have a gradual fall off and not a constant one. And that's how we get that initial sort of extrusion upwards. Now, the next thing we have to do is create the cap of our crystal, the point on the top. And for this, we can use some additional math, similarly to how we extruded our cylinder upwards. I'm going to disable displacement so you can see what we're doing better. But if I added a new map range node like this, by the way, I'm using the Node Wrangler add-on. It's built into Blender. You just have to go into Preferences, Add-ons, and enable it. Node Wrangler. This gives you tons of shortcuts when working in the node editor. For example, I can Control-Shift-Click on things to preview what that's giving us, which is very helpful when working with shaders. So if we went ahead and duplicated our map range node, you can see that we have 0.3 and 0.4 right here. That means we're kind of going from 0.3 to 0.4 on this 0 to 1, or 0 to infinity gradient, this dark to light gradient. We're just taking these 0.4 and 0.3 values and crushing them together. So if we were to lower this 0.3 value to 0, now we're going to get that gradient going directly into the middle. And then we also want to change this from 0.3, or from 0.4 to 0.3, because the top of our crystal will be in this 0.3 range, and so the cap will have to go from this 0.3 to 0 range right here. And if we go ahead and move everything over and add these together, I'll plug in the displacement. If we go ahead and add these two map range nodes together now, like this, we have this nice point right here. And so we might want to use some value nodes just to make everything a bit easier to control. For example, we can have the width of our crystal, which is, for example, 0.4, go into here. And then we can subtract that by 0.1 to get the upper area width, because remember, we want that gradual fall off. And the same 0.3 value is also going to go into here. So now, if we were to increase or decrease this, it would change the thickness of our crystal, which is exactly what we want. Now, if we take a look at this map range node, we have 0 going to 1. And here we have 0 going to 1, which means our initial extrusion has a height of 1, and then our cap also has a height of 1. We probably want the cap to be a bit shorter, so we can do that by lowering this value right here on our map range node. And so just so we have more control over this, we can add another value node and plug it into here. So now we have a slider for our crystal width and a slider for the height of the cap. I'm going to go ahead and organize everything a bit better now, just to make this a bit easier to, make it a bit easier to see what's going on. And there we go. This looks a bit neater now. So this is a vector displacement tutorial, and right now we are only using regular displacement. So let's say we want to rotate our crystal so they can point in all different directions. The issue with normal displacement is our height maps only go up and down. They can only move our vertices upwards and downwards. So if we wanted to have a crystal rotated out like this right here, we couldn't get this overhang in this area right here because our vertices couldn't move left and right with regular displacement. That's where vector displacement comes into play. The best way to think about it is vector displacement is just like normal displacement, but instead of displacing up or down, you can displace up, down, left, right, forward, and backwards because you're working with vectors instead of a single value for your height map. And so we can imagine that if our vector displacement map looked like this and was multiplied by 1 on the z, so it looked kind of like our current height map, but blue, it would displace upwards since z represents the blue value. And I can go ahead and demonstrate this real quick using a vector math node, scale, which is the same thing as multiply, except we have a value instead of another vector, so it's a bit neater. And if I set this to 1 on the z, you'll see that this vector looks blue. And if we go ahead and add in a vector displacement node right here, put this into here, and plug this into displacement, or plug this into vector, I should say, you can see that we're getting some displacement, but it doesn't really look right. And that's because we have to change tangent space to object space. And now you can see that this is working exactly like how our displacement node was working, this little bit right here. So the brighter the value in our height map is, the more it's going to displace upwards. But let's say the brighter the value in our height map is, the more we want it to displace upwards and positively on the x. Well, if we go ahead and increase this x value, you can see that our vertices start shifting over to the x, and we do get that overhang that we're looking for. But before we do that, I'm just going to make what we have so far into a node group, because that's going to make things a bit easier to work with. So I'm going to select all of these nodes, and you might have seen right here there were 2, but I held shift and dragged over them with my right click to create a reroute. And that's going to make it so when I group everything together, this is only a single input instead of creating 2 inputs for these nodes. I'm going to go ahead and name this crystal height. And I'm going to move everything a bit closer together so we can see what's going on. Okay, so now that we have crystal height, I'm going to fix these inputs here. We have these values that I'm just going to move up here so they line up with these values that we plugged in. And if we take a look at this top value, that one is for the crystal thickness. So in crystal height, I can press N to open up this menu, by the way, if you didn't know how to open that. Make sure you're in this node option, not item or tool, but node. And you can change the names of your inputs and outputs. So I'm going to change the name of this one to thickness. And I will change the name of this one to cap height. So there's our crystal height map. I can remove these values. Now, there will be an issue. If we go ahead and preview our vector displacement map right here, upon increasing the x, you'll see that our crystal doesn't actually line up with this anymore. And this can make this can make coloring our crystal kind of tricky. And it's kind of weird why this is happening. If we go into top view, you can see it's straight instead of shifting over with the rest of our crystal. But if we think about it, it kind of makes sense. So we're first using the object coordinates, which means it goes from -1 to 0 to 1 based on our vertice position. And our hexagon takes place in this area right here. And so when we look at this vertice position here, these vertices are going to be displaced in this direction, which is good. That's what we want. That's how we get that overhang. But if we go ahead and look at our vector displacement map again, it's still going to be looking at this -1 to 0 to 1 range, but now it'll be on these vertices that aren't lining up with our actual displacement. Sometimes this can be, or before I learned a cool trick, this was really tricky to solve, but I learned that if we use generated coordinates instead of object coordinates, our crystal will line up. Now you can see that our crystal is now in the corner and it's getting cut off, and that's because our generated coordinates are a bit different than object coordinates. So to make up for that, we can use vector math, subtract, and I'm going to subtract 0.5 from every vector, and you can see it looks a bit more similar now. And this makes it so it goes from -0.5 to 0 to 0.5. So now if we scale that by 2, it should go from -1 to 0 to 1, just like our object coordinates. But now, if we go ahead and take a look at this with our vector displacement map, you can see that in the x it is displacing, or it's shifting over this way. But now our vector displacement map lines up perfectly with it, so that's going to make shading and stuff easier, and just overall it makes what we're doing a lot easier. Okay, so our next step is to add some more controls so we can easily change the direction that our crystal is shifting in and the amount that it shifts in. This is pretty easy. We can look at our scale here. This vector will directly control all of that. And so I'm going to add a combine XYZ just so we can separate this vector into these 3 values. We want to set z to 1. We can even make this z a group input for how tall or how short we want the crystal to be. And then our x and y are going to control that skewing. So if we go ahead and, so let's say we want to make a rotation variable where we have a single value affect the direction it skews in. For example, we set it to 45 and it skews in a 45-degree angle, or 90 and it skews directly to the side. But we have these 2 values that directly control all of that. Well, this is pretty simple to do. What we're going to do is take our value here, and we are going to use a sine wave. And then I'm going to duplicate this node, set it to cosine, and plug in our same value here. And what this is going to do is, if we go ahead and go into preview mode, increasing this value makes it go from -1 to 1 over and over again in a very specific curve, like this. And what's neat about sine and cosine is that if we were to say, for example, create a new vector where x is the sine of a value and y is the cosine, and use that as the position for a shape, increasing this value is going to make that shape rotate around. You can see how x makes it go back and forth like this, and then y is going to make it go up and down. And cosine is offset just enough so it rotates in this perfect circle here, which is cool. That's what we want right there. Now if we went ahead and plugged this into here, and we looked at our height map, and of course go into rendered view so we can see our height map. Setting this to 0, we're going to get this direction here. And so you'd think, oh, well, changing this by 1 would only move 1 degree, but it moves a lot more than 1 degree. And the reason for this is because Blender actually works with radians, or sine and cosine work with radians rather than degrees. And this is pretty easy to fix. We just add a math node and set this to radians. And you'd think when converting radians to degrees, you'd want to set this 2 degrees, but I found that 2 radians is actually the one you want to use. So now if we set this value to say 45, it's going to skew in this 45 degree angle. If we did 90, it'll be 90 degrees from where it was before. 180, you can even do negative numbers, negative 45. Our rotation controls are now working, which is perfect. The next step that we want to do is control how much this is skewing. And if we think about it, our sine and cosine are displacing it from these like -1 to 1 in these directions. So if it was displacing it from like say -0.1 to +0.1, it would be displacing less. And so we can just go ahead and multiply these two by a value here. And this value will control the amount that our crystal is skewing by. So if it's set to 0.5, it'll skew half of what it was before. If it's 0, it won't skew at all. And if it's 2, for instance, it'll do double. We would probably want to keep this relatively low, like say 0.5. So now we've got some additional controls, but you might notice that we have a bit of an issue with our crystal. If I go ahead and set the skew up to 2, just to make this really exaggerated, and I go into this view, you can see that our crystal is kind of getting warped in a weird way. This line right here, where the cap meets the rest of the crystal, is still straight, even though it should kind of be rotated like this. And that's because of the way we're skewing the crystal. We're taking our height map, which looks like this, right? And we move the vertices over based on how high they are. So this vertex will move more, this vertex will move a bit less, these ones down here even less. What this means though is these vertices over here aren't moving up or down, they're just moving to the side, which is why we still have our crystal just sort of sheared in a direction instead of being rotated. And so to fix that, we can generate a sort of gradient pointing in the direction of our crystal. Let me explain this real quick. If our crystal looks like this, and it's skewing like that, we can generate a gradient that goes from 1 to 0, like this. And if we or actually it would need to go from 0 to 1, like this. And if we subtracted that from our crystal, over here we'd be subtracting less, and over here we'd subtract more. So this would subtract a bit less from our height map, this would subtract a bit more, which is going to counteract that sort of skewing a little bit. So we're adjusting our height map to make up for all of that. You may remember when we generated our hexagon shape, we were able to use dot product to create a gradient going in this direction, which we can do again right here. So I'm going to add a vector math node, set it to dot product, and the x and y value that we're skewing our crystal, I'm going to go ahead and recombine these up here. And if we look at our dot product with our coordinates. So everything that our crystal is doing, by the way, we're using these coordinates right here. All of the coordinates that are affecting our crystal are going to be these ones out here. So we're never going to use this value here or this value here for stuff other than these two nodes. We're always going to use these. So if we got the dot product between this vector and a direction, you can see that this lines up with our crystal. And this is what we're going to use to control the this is the gradient that we're going to use to sort of fix the sharing that we get that we don't want to keep. And we can actually just use this same XYZ that we're using for the displacement. So instead of scaling our height map by this, we're just getting the dot product of this vector and this one right here. So that's great. Now, what we're going to want to do is subtract from the z. Because remember, we want to displace these vertices down. So in order to do that, if I go ahead and set this value to 0, or say 0.5, just so our crystal is in a bit more of a realistic position, I want to use this sort of gradient here in order to control this. So if I go ahead and set this to subtract, and we subtracted down on, or I guess subtracted a positive number on the z, like 0.5, you can see that our whole material moves down. And if we go ahead and separate this vector into just the x, y, and z, like this, I'm going to move everything over a little bit, and we use this gradient for our z, you can see that it kind of adjusts for the rotation there. Although it adjusts everything at once. It's not just adjusting our crystal, it's adjusting the ground. And so what we can do is take this dot product here, and we want it to subtract less if it's closer to the ground and more if it's higher up. So for that we can just use our height map here. If we look at this, we have 0 going up to a greater value, and we just want to multiply that on top of our gradient. And so if we multiply those together, you can see that it's no longer affecting our plane, and the issue that we kind of got with this skewing looks much better now. Okay, so our next step right now is to add multiple crystals. The same way we made our crystal height map into a single group to make things easier, we're going to do that with our vector displacement map. So if I go ahead and make sure I add any reroutes to nodes like this where they connect to multiple things, and now I can just go ahead and select all of this, press Ctrl G to make it a group, and I'm going to bring everything closer together again. I'm going to call this crystal vector, and I'm going to rename these values. So here we have the degrees and the amount of the rotation. So I'll call this rotation angle. Right here, let's call it skew angle, and I'll call this one skew amount. You can go ahead and remove these, and I'll leave this skew angle at 0 just so it goes straight this way to make things a bit easier to work with, and I'll leave the skew amount at 0.5 for now. So we want to add multiple of these crystals now. If we were to duplicate this and use vector math, actually, one thing I want to change is I want to take this little node group down here where we fix our generated chords And I want this to actually be on the outside of our node group here for our crystal vector. So I will put that out here. Remember, we subtracted the generated chords by 0.5, and then we scaled them by 2. And there we go. So now it's not inside here, but it's only being processed, or computed once outside now. And so if we just tried adding two of these crystal vectors together, it's going to make our crystal bigger, and that's because these two crystals are in the exact same position. So if I go ahead and move everything over like this, and I use a vector math add. Actually, before I do anything, there are a couple more options I need to add. I need to add this thickness parameter and this cap height parameter that we had before. And one more thing, I probably want to add a control to the overall crystal height, which is this combined XYZ right here. So I'll call this overall height, and then we have our cap height and our thickness already correctly named. So there we go. Everything is how I want it now. Perfect. So now we have much more options that we can play around with. Now if I went ahead and moved this crystal over on the X by, say, 1, you can see now we have 2 crystals on our height map. Perfect, right? And if we turn off displacement and look at our map right here, you can see we have these 2 hexagons that we're moving around. And something important to note when you're placing crystals, you don't want the base of the crystals to intersect at all. And the reason for that is because when adding these together like this, you can see where they intersect, it gets brighter. And so if we plug our displacement in again and look at our 2 crystals, now they're going to have a longer area where that intersection occurs, which we don't want. So I'm going to go ahead and make sure we don't get any intersections with the bases there by moving these over like that. And to make this easier when we're moving crystals around, we can even just turn off displacement and only look at our vector displacement map while just getting the positions of them. Just because the bases can't intersect doesn't mean that our other vertices can't intersect, because if I change this skew angle to 90, you can see that now our crystals are intersecting, but we don't get any weird vector displacement errors. And the reason for that is because our vector displacement map is still just these 2 points. We're just moving some vertices this way, and other ones aren't. So intersecting crystals is fine, the base is intersecting is not. That's really all you are going to have to remember when you're sort of positioning your crystals all over the place. And so I'm going to be taking a look at this. One last thing that I want to do, we can change all these parameters, but what might be nice is if we randomize some of them. The main ones that I'm going to want to randomize are the skewing, the rotation and stuff. The reason I want to randomize those specifically and not everything is because when we change the thickness, that's going to affect whether or not our crystal bases actually intersect with each other. So we probably don't want to randomize that and just handle all of that ourselves. The thickness will do that. The cap height isn't going to affect that, but the cap height will look different depending on our thickness. So we probably just want direct control over that. But if we add some randomness to our rotations and stuff, that's going to make it a lot easier to generate a bunch of variations while still having a good amount of control over our overall shape. And so that's what I'm going to do right here. Right now I have 2 crystals. I can add a value. This value is going to act as our seed. And if we added, say, a white noise texture and used coordinates for this, the denoiser is actually hiding this, so I'm going to disable that for a second. You can see that this white noise texture just generates it generates a random value for each pixel. And if we set this to 2-dimensional, it's only going to have an x and y parameter, so the z won't change anything. If we set it to 1-dimensional now, we just have a single value, and it's going to output a random value for whatever our single input is. This is helpful because we can make 2 white noise textures, for instance, like this. And we can add a small offset to one of their seeds. Now, if we set this value to some random number, each of our white noise textures will give us random different brightnesses, which is what we're going to use to add random variation to each crystal and have this single seed controlling each one. One more trick that we can do is you'll notice our white noise textures also have this color output. That's because they have this randomized red, blue, and green, and this value is only looking at that red channel. But if we were to separate RGB, not combine, if we were to separate RGB like this, you can see that we actually get 3 random values for one white noise texture. And so using this separate RGB, we can actually use 3 times as few white noise nodes, because now with just these 2 nodes, we have 6 unique random values. That's how most of the randomization is going to work. I think I'm going to use, just to make things easier, I'm only going to use red and green to randomize the skew rotation and skew amount, and each crystal will have its own white noise texture. So I can change the seed for each individual crystal if I want to. So if we go ahead and look at this, one thing you'll notice though is these random values are from 0 to 1. And for things like our skew angle, we don't want this to go from 0 to 1. We want to go from, say, 0 to 360. Or here for skew amount, we want to go from, say, 0.25 to 0.75, for instance. And so this is a pretty simple fix. We can use a map range node. I'm going to uncheck clamp, although actually I don't think it really matters in this case. But if we plugged in, say, our green value into our top input, we want to take our 0 to 1 range and make it, say, a 0.25 to 0.75 range for our skew amount. And now, instead of giving us a random value between 0 and 1, we're going to get a random value between 0.25 and 0.75. So you can use the map range node to have lots of control over the minimum and maximum random values. So yeah, I'm going to start plugging things in now. Although in this case, for skew angle, we can actually use a multiply node instead. And the reason is because we want to go from, instead of 0 to 1, we want to go from 0 to 360, which means we can just multiply this by 360, for example. And now we're going to get random rotation for each crystal. So now we have our random skew angle here for each crystal. I'm going to move everything here down a little bit. I'm going to take our multiply node, actually, here. So we have our random skew angle, and I'm going to take map range and plug in our second random 0 to 1 value and remap this from 0.25 to 0.75. Plug this into our skew amount. Might even do 0.25 to 0.5. And this will be how we generate the random parameters for our skewing. One thing that we might want to do is just, to make this a bit easier to work with, is group all of this. So if I hit Control G on this, it does have a vector input, although we don't need a vector input. if we hit Control G on all of this, we can call this skew randomization. And we can have a second value here for our offset. Or I'll call this seed offset. I'll call the top one seed. The first value is going to be rotation. The second value will be called amount. And so the seed offset is just going to change that random value for each crystal. For example, for the first crystal it'll be 0, second crystal it'll be 1, third it'll be 2, etc. And then we can change the seeds for each crystal independently, or all of them together with this seed value. And now I'm just going to take this add node here. I've got this skew randomization that I'll put into the correct spots. And I'm just gonna start adding some crystals. So I'll do a time lapse of that. Okay, so one thing that I noticed when I was positioning crystals around is, if we look in rendered view here, I've placed all of my crystals in the correct positions. I still have to mess around with the seed for rotation and everything. But even the thinner crystals have different, or have the same height. And so I want the thickness to be directly proportionate to the height. I actually want to remove this overall height input, or change what it does at least, because currently it only changes the z value, but I want it to just directly change the scale of the entire thing. So if I go ahead and add a scale node at the end of our vector displacement and set this to say 0.5, you're going to see that all of our crystals are going to get shorter. And so I want to put maybe not even overall height in here, but thickness, because that'll be directly proportionate to the scale of our crystals, and then maybe multiply thickness by some larger numbers. So there we go. Now our thinner crystals are going to look much shorter, which is what I want to do. I still have to mess around with like the caps and everything for some of these. But for the most part, this is looking pretty good. Yeah. Okay, so I've done all the placements of my crystals. I've messed around with the seed until I got something that I like. And here I am encountering an issue with the vector displacement. This is an issue that is going to happen pretty frequently when working with vector displacement. You might notice that the lighting looks kind of weird on this. The normals are all messed up. This is a pretty simple fix. When working with normal displacement, you usually use this displacement and bump option. But with vector displacement, you actually don't want to use that because it's going to cause all sorts of errors. So if we go ahead and switch that to displacement only, you're going to see our lighting is fixed, ambient occlusion, shadows, everything looks much better now. So that's going to wrap it up for this first part of the tutorial. Part 2 will release sometime in the future, where I'll go over the actual shading workflow that I use to make these look like crystals instead of just a crystal-shaped display set of a plane. But thanks for watching. I hope this was helpful to you. If you have any questions, comments, concerns, go ahead and just leave a comment. Thanks for watching. Bye.